Thanks again for having me. Okay, so I will share my screen and so contribute to the outline for today. Okay, can everyone see my screen?
Yes, we can.
Yes, done.
Okay. Okay, so yes, I'm going to start. So first off, we start off with basic blockchain. I know as in the other teachers in Bootcamp, the other uh, other friends would have maybe spoken about blockchain and Ethereum concepts to a large extent, but I will just do a little refresher. What I'm going to do today is kind of like give a little more detail into these things. Definitely, there are levels to this to blockchain technology. So the aim is not to go extremely deep in the way so that this at least the 1 hour we have would be enough. But we just go deep enough to make you curious, kind of like so that you are able to explore it yourself and explore it comfortably yourself. So that's the aim of this particular lecture for today. Okay, so yes, so I will proceed. So yeah, the Ethereum, the blockchain, as we all should know now, is simply a decentralized network um, of information, right? So in the context, in this particular concept, we have a decentralized ledger, um, but I would like to call it in my own as a software engineer, right? I would like to call it a decentralized state, right? Because the state can be anything, but of course, um, to make it kind of like familiar to people, we do use the concept of ledgers, but theoretically, it's a decentralized state. So this decentralized, the beauty of blockchain technology is that it's decentralized and censorship resistant. So I will quickly um, go through my key points. So the Ethereum blockchain in particular is unique and is different from other blockchains. For example, I'm sure we all would have heard of the Bitcoin blockchain. So the key difference between the Ethereum blockchain and um, the Bitcoin blockchain is that Ethereum is able to process programs, like it's able to run little programs, unlike the Bitcoin blockchain. The Bitcoin blockchain is designed exclusively for processing financial transactions, right? Bitcoin transactions. Yes, there is a scripting, there's a limited scripting feature that the Bitcoin blockchain does have, but it's very limited and it's not powerful. I would even dare to say it's not Turing complete. I hope I'm correct in this regard. But what I'm basically saying is that it's not as powerful as the ability of Ethereum to process applications. So what does that give you? Like, so what does that mean? Okay, the blockchain is able to process applications, right? So what it simply means is Ethereum, in short, is a decentralized computer. So that's the key difference from the Bitcoin blockchain. The Bitcoin is a decentralized financial network, but Ethereum is a decentralized computer. So you actually get to run programs on the Ethereum blockchain, right, via smart contracts. So we'll talk more a lot about smart contract later um, in the presentation. Maybe not today. I think that should be the last class. So yeah, so that's the very unique thing about the Ethereum blockchain. It's ability to process application, and it does that with the help of Ethereum. So that's my very first key point here. And yes, you can also process financial transactions on the Ethereum blockchain, but that's a side effect because for every work that is done on the Ethereum blockchain, you have to pay for it, right? So because you have to pay for it, so Ethereum has to have a means of payment. So that's why you have ETH, for example, which is the native currency on the Ethereum blockchain. So yes, a lot of people would know about ETH and know it in a pure financial sense, but really its purpose is to be able to pay for computational work that is done on the Ethereum blockchain. Yes, computational work and other fees that is done on that required on the Ethereum blockchain. That's the main purpose of it. Unlike Bitcoin, which is solely designed for P2P payments. So that's the key difference between the Ethereum blockchain and Bitcoin blockchain. So at this point, I will just pause in case there's any question and this is a suggestion. Okay, I think someone is saying my voice is not clear. Please, is this a general problem? Can everybody hear me clearly, or is it localized? So
I can hear you over here, so I don't know. It might be a network glitch, but I think they should see your shared screen clearly. So yeah, okay, it's clear. Thank you. You can continue. Thank you so much.
Okay. Thank you very much. Okay, so I'll pause a bit for any questions so that we can make the presentation as interactive as possible. If you have any question, you can drop it in the chat. I'll just quickly read it. Okay. If there's no question, or while I'm looking for questions, I would love to keep some time because we really have a lot to do today. Okay, so the next key point about blockchains, which I'm sure would have been revealed to us already, is that it's decentralized and secure. So what it simply means is there is no central place where decisions are made, right? The Ethereum is software that everybody can download, connect to it, and partake in whatever is happening on the blockchain. There is no central processing area. So what that means is it's almost impossible to bring down the Ethereum network. Like if you want to bring down the Ethereum network, you would have to literally find everyone who's participating in the network and shut them down or disconnect them from the internet. And that's very difficult to do. And it's also very resilient. If you shut anybody who is running the Ethereum node down, for example, the person can restart his node or reboot or join using another network or through another node, and that's it. So that's why it's censorship resistant. I think that's the point I should. I think it's under my why. So that makes it censorship resistant. That means it's very difficult for example, governments to be able to shut it down because there is no known address. There's no singular known address, network address that people will say, oh, yes, this is an Ethereum node. Let's block this address. If that address is blocked, the person running the node will just connect to different network, restart the node, and get a different IP address, and that's it. And broadcast that IP address to all the other Ethereum pairs, and he or she is back up. So that makes Ethereum or any other blockchain, any other decentralized blockchain, very censorship resistant and hard to bring down. And it also makes it very resilient to network failures, and it has a very high uptime. So the Ethereum network has a 99.9999 kind of like SLA when it comes to availability. right? So it's always available. That's one of the beauty of blockchains. So I hope this point is clear. So to recap, it's decentralized, meaning there's no central place where processing happens. The processing happens on the on the machine or the computer of every participant in the blockchain, and this also makes it difficult to bring down the network, and this also makes the network available all the time, because even if someone's computer goes down, there are other computers that or nodes. So from here henceforth, I'll use the word node. So a node is simply a computer running an Ethereum software, right? Yeah. So even if 10 nodes go down, right, that's computers. There are other computers that will be able to serve requests on the network. So this makes it very resilient. So that's just a recap. Okay. If there's any question, send it in the chat while I move on to the next point. So yeah, so points 3 and 4, the Ethereum blockchain was conceived around 2013 by Vitalik Buterin. He's a Canadian, he's a Russian name, like he's a Canadian citizen of Russian descent, right? And he got inspiration from the Bitcoin network. So if you look at the underlying technology of Ethereum, you see a lot of similarities to blockchain. When we talk about encryption and address and stuff like that, you see there's a lot of similarity. So they were, I would say, Vitalik was inspired by Bitcoin blockchain and just added programmability, that the ability for a blockchain to run programs. That was the unique thing he added to the blockchain technology that Bitcoin introduced to the world. So, and after conceiving in 2013, by 2015, they launched the first Ethereum network. So that's point 3 and 4. So to recap, Vitalik Buterin was inspired, probably I would say, yes, inspired by the beauty of the Bitcoin blockchain, and decided to add the ability for blockchains to process applications, right? That was the unique thing he added to it, and of course, other beautiful features, and to then release it to the world. So that's that for points 3 and 4. Okay, then 5.5. So in the Ethereum blockchain, there are primarily two participants. They are the validators and the clients, right? So the validators are the guys that, what do you call it? They're the guys who ensure that whatever the transactions that are going to the network are processed properly, right? They are validated. They're the ones who ensure, okay, fine, they vote or do heavy lifting, heavy work required to get transactions flow to the network, right? That's their work. So they're like the workhorse of the network. And they're the clients. The clients are like the everyday users, right? People who want to perform operations on the network. People like you and I who want to send it, right, from one person to another, or who wants to perform an operation who wants to perform an operation on the Ethereum blockchain. So those are the clients. So we don't do the heavy lifting. Clients don't do heavy lifting. They just say, I want to send money to this person, or I want to execute this operation on the network. So that's what clients do. Then the validators and or miners, as it was previously, are the ones that receive these transactions, these requests from clients, and validate and take action on it. So those are the two participants in the network. So those are the things. Okay, I can see a question. Mustafa Yusuf said, does that mean you can't create app on Bitcoin blockchain? Yes, you can create apps on Bitcoin blockchain. The Bitcoin blockchain is primarily designed for peer-to-peer financial transactions, sending Bitcoin from one person to another. Okay then, sorry, Oluwashio, let me just look at that said, please can you elaborate more on BTC miner? Yeah, so a BTC miner is it's just like I spoke about now. They are the people who do the heavy lifting in the blockchain in the Bitcoin network, right? So what they do is when you send a transaction to the Bitcoin network, right? Um, before you get the rights, right, to process that transaction, right, you have to what we call the proof of work, right? You have to prove that yeah, you are a validator and you have invested enough time and energy to make decisions in this network, right? So in order to do that, you calculate. There's a math problem that you have to solve, right? When you solve that math problem, then you have the right to create a block. So what does creating a block mean? So it means you then pick transactions that people have. Transactions are like just like requests that people have made on the network, right? You then pick some of those transactions and you put them in a block, right? You put them in, and of course, as part of because you have the right to create a block, you can also create a transaction that rewards yourself too. That's that's one of the reward of being able to create a block on a BTC network. So you have the right to create a block. When you create this block, you put any transactions in it, and then you kind of like create the block and send the block to the other miners who will then verify that all the transactions you have in this block are legit. And once they agree, then it's final. So that's what the Bitcoin miner. That's what we do. So I won't want to digress too much on Bitcoin, so I can have enough time for Ethereum because they are the reason why I think we're focusing on Ethereum is Ethereum gives you way more power, gives you the power to do way more, and of course it's like the Ethereum is the main enabler of Web3, right? Why Bitcoin is just a financial transactions platform. So so that's that. I won't want to go too much into Bitcoin, but of course maybe in another meeting, I can, if AKARA Africa organizes that, I can speak more on Bitcoin. Okay. So yes, so that's that for the just a light introduction to the blockchain, the major participants, and the key features of it. So if there's any question, please drop it in the chat. I'll take a pause for a bit so that we all can digest what I've said and we'll move on. So DJ, if you could maybe, if possible, if you could play, let's say, a minute of music just to get people relaxed while I go to the next topic. And while this is going on, if there any question comes to mind during the talk, then you can just send it via chat. I will respond to you. Thank you.
Yeah, thank you. So our DJ, Miss Zainab, can you give us 1 minute music to calm the nerves of our participants before we take another flight? Thank you so much.
Okay, I'm still questions here. Um, Emmanuel Chiku said, does that mean building a website on each network automatically means that the website will also have a DApp without building separate apps just like Web2? Okay. Yes. To a very large extent, there you can actually build uh, a how do I put it? Ethereum allows your enables makes your if you build any application. So the difference between a Web 2 application and a Web 3 application or a DApp is that a Web 3 application is inherits from the censorship and distributed nature of the Ethereum network, right? So, for example, there is the what do you call it? There's a distributed file um, sharing blockchain. I think I remember that I think it's Filecoin. I've forgotten the name of the blockchain now. So what they do is they actually it's a decentralized way to store files, right? So it's actually possible to actually write applications that you would set on a decentralized hosting platform, right? And um, the data is stored on Ethereum, like the programming logic is on Ethereum, right? So it's fully decentralized. So it's yes. So Ethereum allows you. But anyway, it's kind of like hardcore. But most people don't really do that. What most people do is they build their application like a normal standard Web 2 application, but the the business logic is powered by smart contracts that run on Ethereum. So yes, so that's the major difference between the Web 2 app and the Web 3 app and the Web 2 app. So in Web 3 or DApp, the business logic is powered by smart contracts that are on the blockchain, right? And that allows the application to be censorship resistant. And meanwhile, in Web 2, you have to host your business logic in your own servers, right? In your own, uh, maybe AWS or which other hosting platforms. So that's so what that means is your application inherits the censorship resistance and centralized properties of the blockchain. And again, you have to build a web. So the interface, right? So your application is a normal Web 2 uh, interface, like, but it's more of front end logic, like, right? So you have to use things like Vue or React to build the front end. Then the back end is smart contracts, right? So for Web 2, you have a front end and you have a back end. Your back end can be built in programming languages like maybe Node.js or Golang or Rust. Um, but for Web 3, the backend is on Ethereum, right? Backend is smart contract on the Ethereum network. Yeah. So what do you mean by censorship resistance? Yeah. So censorship resistance means you can't shut down the network because there is no singular address. The network doesn't have a singular address. You can connect to an Ethereum network by finding the address of anybody who is participating. It's a peer-to-peer network. So all you have to do to connect the network is just find the address of someone who is running Ethereum. That will connect to the network. So there's no singular address. So there are thousands of addresses. So you can't shut all the addresses down. Unlike Web 2 that has a fixed, either a singular address or a fixed set of addresses. So because you know the address of fixed set of addresses, you can just ban the website in the country. So Nigeria can say we no longer want Binance in Nigeria, right? What they do is they just block Binance on PNS level. So when anybody tries to go to Binance.com, if that what they do is the government will send a request to people, just the way they block Twitter in Nigeria, for example, right? So the government will just give an order to the telecoms network or the internet providers in the country and say block any request um, going to any server associated with Binance.com or any request, any DNS request to Binance.com, block it, and you can easily block it. But for Ethereum, there is no, it's just IP addresses, and there are thousands, right? So you cannot, so even if you block all you want to do, you want to spring up tomorrow. So that's what it means by censorship resistance. It can't be blocked by government. Okay, so I think I will jump on to the next section. Thank you very much. Okay, so yeah, so in this session, let me just start sharing the screen. So I would like to spend maximum of 15 minutes or 10 or 15 minutes on this section. So this section is a very, very critical section, but um, I'm just trying to put them to 1 hour, so I would just try to pass. So consensus is a very important thing when it comes to blockchain, right? So, for example, if I say I have a balance of 1,000 on the Ethereum blockchain, right? Everybody has to agree that I do have that 1,000, right? Everybody has to agree. If every like if everyone does not agree, then there's a problem, right? So because if I say okay, I have 1,000 each and I want to send 10 each to someone else, right? Um, because the blockchain and everybody on the blockchain agrees that I have 1,000 each, then that now makes it possible for me to send 10 each to another person. If the blockchain does not agree that if everybody on the blockchain does not agree that I have 10 each, then or that if everybody on the blockchain does not agree that I have any it at all, then it will be illegal for me to try to send it to someone else, right? So that's like what consensus is. So for the theoretical definition, consensus for blockchain is a procedure in which pairs of the blockchain network agree about the present state of data in the network. Through this, consensus algorithms establish reliability and trust. This is a very key word, trust in the blockchain network. So um, blockchains are designed to be trustless, right? And what makes blockchain trustless is consensus. Because everybody agrees, you don't need to. So you need trust when someone says this is how this is, and you can't question it, right? So when you can't question it, you have to trust. Just like in the case of religion, right? The Bible says, uh, if you die, you go to heaven. There's no way to verify, right? Nobody has gone to heaven and come back to tell us. So you need trust to believe it. You get right, but on the blockchain network, no, we don't do trust. Everything has to be verifiable, right? So if I tell you I have 1,000 ETH on the blockchain, everybody has to agree. So that's the importance of consensus on blockchain network. So the key points here are Byzantine fault tolerance, right, and Sibyl resistance. So what's Byzantine fault tolerance? So what this means is um, if if I have um, if I have 1,000 ETH, right, everybody agrees. Tomorrow, if I all of a sudden now have 1,500, right? Everybody has to. There should be a way for people to say, "Come on, how did your balance go from 1,008 to 1,500?" Right? There has to be a way for everybody to know. And what? And how would I put it now? Um, what if I found a way to increase my balance and fooled everybody to believe, right? What if I said, guys, I have 1,500 hits, and I was able to fool them to believe it because I know something that everybody that person does not know, right? So that's a risk on the blockchain because the blockchain is decentralized and everybody is participating. So someone can literally lie, right? And that lie can become truth if I find a way to fool everybody on the network to believe the lie. Do you get? So blockchains are designed to be Byzantine fault tolerant, meaning in under any condition, there should be no way for somebody to be able to fool the network. So that's the importance of that's what in layman terms that's what Byzantine fault tolerance means. There should be no way for someone there should that there should like we have there has to be zero possibility that it's possible for someone to fool everybody on the network. So nobody can fool us on the network. If you say you have 1,500, then there must be a way to prove it. So that's the layman definition of Byzantine fault tolerance. So I'll just give a little theoretical background to it. So Byzantine fault tolerance stems from the Byzantine general problem. So if you have the Byzantine general problem, just imagine the city, right? You have a city, and there's a group of generals that have surrounded the city, right? And for these generals to be able to successfully attack the city, they almost attack at the same time. And the city is very big, right? Just imagine there's no GSM, right? There's no means of digital communication. The city is very big, and the generals are in different areas around the city, and they almost attack at the same time to succeed. If one general, if let's say there are 10 generals, if 5 generals go before the other 5 generals, they will lose, right? Because for them to succeed, the 10 of them must attack all at once, right? So how do we ensure that all the generals attack all at once? What if there are some generals that have been bribed, right? What if they are now? So okay, fine. Because there's no digital means of communication, we have to send these messages with, let's say, horse riders, with messengers. What if the horse riders are corrupted, are spied, right? So how do we ensure that, one, all the generals are who they say they are, and the messages are carried by people that we trust? This is the only way that we can successfully attack the city. So my enemy, knowing this, can go and plant bribes from generals, plant false messengers. So that's the problem when so many people have to decide all at once on a particular issue. You have to deal with people that are corrupt, people that pretend to be who they say they are, but are not. So that's the issue you have when a lot of people have to decide, and that's the problem on the blockchain. On the blockchain, you have many people. Many people just connect and take part in the process, but you don't know who they are. They can be corrupt people. So how do you not ensure that your network performs optimally, regardless of the intention of anybody? So the truth is, there is no easy solution to that problem, because human beings are human beings. There's no way you will know if someone is a corrupt person or not. The only way you can prevent that kind of situation is to agree on a set of rules first, before the generals even go out to war. Do you get? So the solution to the Byzantine generals problem is, all the generals must first of all establish a modus operandi, right? An agreed way to communicate securely before they go out to attack the city. So that when they get there, they will now use the protocols they've established. For example, there could be things like secret word. So if a general sends a message to his other generals that let us attack now, right? There might be a secret word that he has to give to the messenger, right? And before you even, then the messengers have to be vetted before we even go out to fight the war, right? We have to vet all the messengers that, okay, these messengers are who they say they are. So all those things have to be established in our base before we go out to war. So that is literally the solution to the Byzantine generals problem, and that is what we often do in blockchain technology. So in blockchain technology, there are protocols that are built into the code, right? Into the client and the code. So these protocols are established ways that we communicate in order to make the network Byzantine fault tolerant, in order to make the network resilient in a way that nobody can fool anybody on the network. So that's why you have things like encryption, right? That's why people have to sign messages with their private keys so that messages cannot be forged, right? That's why people have to prove that they're not bad actors. So that leads into the second point, which is called Siberian resistance. So Siberian resistance is, how do we ensure that the generals or participants in this network, right, are who they say they are? And they're acting independently, right? So I will just take a pause. Let me take some questions before I proceed. Okay, so Mr. Faisal said, what if the bad generals are more than the good generals, and the decisions of the bad generals overcome the good generals? This is a very good question. So, thank you for this question. I would have skipped this very important part. So, the thing is, because, like I said, there has to be an established way of um, agreeing to things, right? And people have to vote, right? People have to vote. People have to. Um, so this, so I think let me just cut more of this in typing resistance. Let me just use typing resistance to kind of like answer this. So you said this. You said, how do we know that the good general? How do we know that the good general? What if the bad generals are more than the good general? So one, um, in terms of how do we ensure general participants are all acting independently, and I would then add in the interest of the general network. So the question is, we vote, right? We vote, and we have an established means of ensuring everybody acts in accordance with the interest of the network. That's why we have different means to achieve this. One of the means of achieving this is proof of stake and proof of work. So in proof of stake, right, the generals or participants have to drop money, right? They stake money so that if we find out that they are bad generals, we can punish them because they've already deposited money with us already. So fine, you can be a bad general, but you have deposited money. If you if we do find out, because we are going to agree on a means to verify our actions and decisions, right? So if five generals agree that if five bad generals make a decision, right, and four generals kind of like find out that, okay, I think uh, there's a um, there's a rule here that I have to point out. In a situation where the bad if the bad generals, right, are more than the good generals, the truth is the decision of the bad generals is going to actually stand, because they have to vote with the Byzantine as one of the solutions to the Byzantine postulate. So the truth is, if a majority of people or a majority of the generals are bad, right, or take a bad decision, then that bad decision will actually stand. That is the truth. That's why one of the main challenges in blockchain networks is that um, you ensure that people are acting independently. So, and acting independently and acting in the interest of the network. So that's the reason why I maybe highlight independence here. So because yes, if majority wins in that kind of situation, if majority of the generals agree to something, whatever they agree to, whether good or bad, stand. So we have to also ensure that we have protocols in place to ensure that the generals are acting independently and are acting in the overall interest of the network. So that's the key things. I think so. That's my answer to you, Yusuf. So uh, if bad generals are greater than the good generals, then their decision will obviously stand because it's democratic. The voting is democratic. So that's it. So we have to now ensure that there are no bad generals. So one of the ways to ensure there are no bad generals is one, by ensuring that in proof of stake solve this by ensuring that, okay, the generals deposit money, or the participants in the blockchain network um, deposit money. If anybody else finds out that these generals are making bad decisions, then, or any general is making bad decisions, then they can be punished by seizing the money that they have deposited. Then in proof of work, the generals or the participants in this program have to solve, have to invest energy in terms of computational power, and to get that, you have to invest your money, right? To be able to get the right to make a decision. So that's one way to ensure that anybody who is making a decision or who is participating is able to kind of is one, acting in the interest, overall best interest of the network, and two, that a bad actor cannot spawn fake identities. So that's another very important feature of cyber resistance. So we have to ensure that, because it's a digital network, right? So one person can just have five nodes or five participants. Like you can have one bad person create five bad profiles, right? Or 10 or 1 million bad profiles and swarm the network and just kind of like start making bad decisions that is against the overall best interest in the network. So proof of stake and proof of work also helps to combat that. So in case of proof of stake, you need a lot of money, right, to be able to turn a lot of bad actors, because each of the actors have to deposit money, right? And the money that each of the actors deposit determines their weight and their voice in the network. So to be able to create a lot of bad actors that have a voice, you have to spend a lot of money, right? So that makes it difficult for someone to just corrupt the system. Then in proof of work, you have to invest a lot of money too, because you have to solve mathematical problems. And to solve mathematical problems in a digital network, you have to buy high-end computers and GPUs. You have to invest in electricity. You have to invest in RAM. You have to invest in a lot of compute resources to be able to even make one decision. So if you want to have 1,000 bad actors or even two bad actors, you spend a lot of money, right? And for example, in case of proof of work, the difficulty in being able to make a decision in proof of work becomes harder over time. So as the network grows and handles lots of transactions, the ability to be able to make a decision becomes even more expensive. So that would mean if there's any bad actor, it becomes exponentially more difficult for a bad actor to be able to take over the network and make bad decisions. So I believe we all can see the importance of cyber resistance. So cyber resistance helps to ensure that one, you don't have um, more bad actors, right, in the network. Or cyber resistance makes it very, very expensive for people to be bad actors, for there to be bad actors in the network, right? So that the people who participate, one, are independent and they're not bad and they're acting in the overall interest of the network. Then two, um, yeah, yeah, I think yeah. So the aim of cyber resistance is that the people who are participating in the network are acting in the interest of the network, and they are not bad actors. And if they are bad actors, it will take them, it will make it exponentially difficult for them to be able to influence the network. Not impossible, but exponentially more difficult over time. So that is um, the importance of cyber resistance. So to recap, a blockchain network reaches consensus by ensuring everybody agrees, right? And that agreement must be in the overall best interest of the network. And to ensure that the network must be Byzantine fault tolerant, meaning everybody must reach a decision at the same time, and that the decisions that everybody reach are not corrupted along the way, right? And two, that it's cyber resistance, meaning there are no bad actors in the network, and that it becomes exponentially difficult for someone to be a bad actor in the network if anybody chooses to be a bad actor. So this is the importance of consensus encryption. So um, okay, so there's a question. Hi. Please, everyone is actually intended in the network. Who actually checking if anyone isn't acting in who is actually checking if anyone isn't acting in the interest of the network? So that's the okay. So the interest of the network is to ensure that what every the voice everybody says what they mean and they mean what they say, and what everyone says in the network is what they say is actually what they said they want to do, right? So the problem in the network is copying other people's decision, right? Or 10 people um, in acting dependently on each other, or acting in unison, right? Or a majority of people acting in unison to achieve something that is not in the interest of the investor. So, for example, let's say um, someone says I have 1,000 bits, right? And all of a sudden, that person, because it's hated by, let's say, a bad actor, maybe, let's say, some group of hackers, right? The group of hackers want to find a way to um, defraud that person, right? Then they spin up, let's say, 1,000 fake identities easily, and then tell the network that no, this person has zero hits. He does not actually have 1,000 hits. And because the majority, everybody then agrees that, oh, okay, since majority says you have zero hits, then you don't really have 1,000 hits, right? So that's how bad actors can actually influence the network. So the goal of cyber resistance and Byzantine fault tolerance is that one, bad actors cannot kind of like come together easily to make such bad decision, right? It's not that it's not impossible. So that's the point here. It's not impossible, but it becomes the aim of cyber resistance and Byzantine fault tolerance is to make it extremely, extremely difficult, right? Okay. Okay. Let me quickly just finish. So it's to make it difficult. So that means if I say I have 1,000 hits, right, the economic incentive for any other person to say it's a lie, right, becomes self-defeating. So meaning if I have 1,000 hits and I really have 1,000 hits, the incentive for any other person in the network to say that's a lie becomes kind of like self-defeating or negative, net negative for that person. So because it's net negative for me to forcefully challenge someone else's truth, I would not want to take part of. I would not want to do it. So that's what proof of stake and proof of work tries to achieve, right? So that's the importance. So explain proof of stake to please. Okay, proof of stake simply means for me to be a participant in a network, I literally deposit money, right? I will buy it, or let's say yes, I have to buy it, right, and deposit it and stock it, lock it up in as part of my requirement to be able to partake in the network. So why I lock up that money is so that if I am found to have lied against somebody, right, or if a group of people have been found to have lied against someone in the network, they can be punished by withdrawing, by denying them access to that stake or eats that they have locked up. You can always redeem your eats, right? So if you want to redeem your eats, you can redeem it. When you redeem your eats, you're no longer a participant in the network, right? But if you want to participate in the network and make decisions, you have to stake money. Like you put your money where your mouth is, literally. Yes, exactly. So once you do that, you then have right to make decisions on the network. Then if you are caught to have lied against any other person or made any bad decision, then that you can deny access to that. So that's one of the ways to ensure that everybody is acting in the overall best interest of the network. So it's just a game theorific way to ensure everybody acts in order, right? So consensus is a very big topic, and I would have loved to maybe have 1 full hour to explain it, but I only have 1 hour, and I have other things, so I can't really spend. I'm just compressing everything, so maybe it might not be clear to some people. Maybe some of my explanation might still not be clear, but maybe in the next class I also have time to explain more. Okay, let me take this question. So that means proof of stake comes before proof of work. Okay, no. Proof of stake. Sorry, proof of stake. Proof of work. All these things I'm talking about, trust of the network, right? Meaning there's no benefit for them to behave poorly in the network. If you behave poorly in the network, you can be punished. So proof of stake achieve that by making sure you deposit money, so that if you are caught to have done any bad activity, you can be punished by losing access to that money. Then proof of work makes it very, very difficult, right, for someone to even get the right to make a decision. So in proof of stake, for example, someone is chosen randomly to the decision. Anybody who has enough, right, is chosen randomly. Pseudo randomly, not completely randomly, pseudo randomly. There are other factors that are up. But everybody is given the right to solve a problem. So the person who has enough resources to be able to solve that problem then gains the right to solve that problem. And if you eventually gain the right to make decision, make that decision, and you make a bad decision, right? Every other person, the other validators in the network will find out, and you be denied access to whatever benefits that was supposed to accrue to you by being the one who won the lottery. So proof of work is like a lottery where everybody is given the right to perform a very hard problem, and the first person to solve the problem gets to make decisions, right, on behalf of the network. And if you make a bad decision, you lose your benefits. And the benefit is being able to reward yourself with it or Bitcoin, for example. You lose that benefit if you make a bad decision. Then in terms of proof of stake, you lose the access to the money that you stake to the network. So that's how. So proof of work and proof of stake, they are different strategies to ensure that people behave appropriately on blockchain and they don't um, um, lie against each other or make false statements, even and that. So that's the overall proof of stake and proof of work. So that's it for consensus. If you have any questions, you can just shoot, and I would proceed to the very last proof of stake. I know I've kind of like tried to quickly summarize it, and I understand if maybe some of you would maybe not be very clear on some parts. Maybe if I'll just in the next lecture, maybe you guys can write down your questions and bring it up, and I'll try to address it perfectly. Thank you very much. Okay, I'll just take a pause before I move on to final topic of the transactions.
You're still doing it.
So hi everyone. I don't know if any of us have any other question. Our session was more interactive. I love our questions. So I don't think there's any question on the chat box, Mr. Samuel.
Okay. So I'll just continue.
Thank you so much.
Yeah. So yes, so transactions are literally performed by mostly performed by clients, right? And they're just a way to say, I want this to get done on the network. So transactions are literally orders, right? Literally, like, well, in most part, they're orders to get something done on the network. So let's say I want to transfer money from my account to someone else's account, right? Or I want to interact with the program. Or the next, those are what transactions are, literally, in simple terms. It's not very complex. I would actually want to, I would maybe do a little demo to just show how this actually works. So an Ethereum transaction refers to an action in externally owned account. So like wallet addresses. So we talked about wallets and addresses in some classes. So meaning, for example, the Bob send at least one hit, Bob's account was debited and Alex's account was credited. This saves changing action takes place within a transaction. Transaction is just oh sorry, my screen is not sure. Oh sorry, I just stopped halfway. Yeah, so transactions are a way to order something to be done on blockchain network. Either you're sending money to someone else or you're interacting with a smart contract program on the network. So very simple. And this is the primary way to get started on the network. So key points, encryption and signing, right? So when you make a transaction, it has to be signed. So remember when I talked about the Byzantine fault tolerance problem, And I said one of the ways a blockchain achieves Byzantine fault tolerance is that messages are messages are kind of like signed, and they are from whom they say they are, and they say what the sender said. Messages are literally what the sender said where they are or where whatever, right? And they are not, and they can't be tampered with. So that's one very critical action. So, for example, if there was a way to corrupt transaction, right? So meaning every transaction must be encrypted, signed, so that whatever intention in that transaction, because in earlier than in a blockchain, they have two participants. They are the validators and they are the clients. So the clients are the people who literally make transactions, who kind of like initiate transactions. That's like your everyday people, like your everyday users of blockchain technology, like the mom and pop and every guy or girl, right, who set it from one person to the other or who interact with the smart contract. So those are the clients, right? Or those are the participants that they get those transactions done via their clients. So a popular clients we all know is MetaMask. And so MetaMask is a popular client that we all know that is this MetaMask is a very popular one. There are other um, uh, MetaMask is the wallet, by the way, right? And wallet are kind of like uh, a, a client component, right? Um, so there's a Coinbase wallet. Uh, so yes, I will have to make this distinction. So MetaMask is a wallet, right? But a wallet is a client component. So for you to um, clients in blockchain network have different components, and a wallet is a part of that kind of like of that idea. I will show you the other component. So your wallet is like your interface, right? That manages your access to your client. So you use your wallet allows you. Your wallet primarily holds your keys, right? They hold your cryptographic keys that you use to sign whatever transactions you want to carry out from the blockchain network. So if I'm sending money from my account to someone else, I would use MetaMask, right, to sign that transaction so that nobody can change that transaction when it gets to the network. And when it gets to the network, the transaction can be processed accurately. And that is one of the key components of a Byzantine fault tolerance network. That messages are never tampered with and corrupted. So MetaMask is one of them. So MetaMask, like I said, is a component. So MetaMask is the wallet, and it's a component. So MetaMask interacts with the the client, and that client is um, for the Ethereum blockchain is called Get. So, um, so Get is an Ethereum client that you can actually download. Um, so Get is one. There are different other. You can actually download it, and there are other flavors of the Ethereum client that are written in other languages, and you can download it. So I have Get. So Get is kind of like an acronym for Go Ethereum, right? And I have the CLI installed on my computer. So there's Get, there's also Ganache, right? There's Get and there's Ganache. So Ganache is also a client. But Ganache is kind of like is a client for testing features of the Ethereum network. So it's not um, So you might not. So for those of us who are who would be kind of like building blockchain applications, right? We would get we would meet Ganache along the line. So Ganache is also an Ethereum client for working with Ethereum locally. So yes, so that's how a client works. So I have Ganache running on my computer, right? Let me just shut it down and start it. So I have Ganache, I have Get. So this is Get. So to start Get, this is how you start from. But most people would not need to. Most people would never need all this, right? I'm just showing this to give you guys, to show you guys what really happens behind the scenes. So for example, when you use MetaMask is going to communicate. Like I said, MetaMask is a wallet. The wallet is the component, it's a client component of the Ethereum blockchain. So MetaMask would interact with a client, a core client somewhere on the internet, right? And this is how the core client would be. This is exactly wrong. So I would point out some things if you can see my screen. So if you notice, see this line here. It says looking for pairs, right? What this means is I've started the Ethereum client and it's looking for other Ethereum clients all over the world to connect to, right? So it won't find any because I don't have I don't have a seed address that is true that to use to find others. So it will just keep looking for pairs all over the world, right? If I had a seed address, it will start finding pairs and connecting to them. But I don't want to go that far because you start downloading blockchain data and it's quite heavy. So, but this is how your Ethereum client works. So this is how it runs either on a local computer or somewhere on someone's computer on the internet, and you connect to it via the wallet, right? So, so let me shut this down. So that's how that works. So you start it up, it starts connecting to the internet, and starts fetching the data. And it will expose endpoints that allows wallet to connect to it. So your blockchain is a local Ethereum, small Ethereum blockchain that's used for demo purposes. So I'll start Ganache. So Ganache is an Ethereum client, just that behaves like that, has a small blockchain behind it. So I'll start Ganache, right? And I have some accounts here already with 1,000 WBits. I think you can see my screen. So now I can connect to this network. So if you notice, let me see, so if you notice, so there's this line here saying listening on port 8545. What this means is the client is up and running and is ready to accept requests from wallets from wallet on my computer, locally on my computer, right? If it was on the internet, to be ready to accept requests from different wallets from all over the world. So that's how the Ethereum clients work behind the scenes. So these are the things that most of you will not see if you're not deep into Ethereum, but these are the things work behind the scenes. So now I will connect to it with MetaMask. Sorry. So this is MetaMask. So oh wow, so we've already exceeded 1 hour, but please I will run out very soon. So I'm already connected to the network. So on MetaMask, you can connect with different networks. So the first one is the Ethereum mainnet. So this is the real Ethereum network. But for the sake of this demo, I'm not connected to the Ethereum network. I'm connected to my local Ganache network. Yeah, so I can do them, right? So I'm connected to the local Ganache network. And so I've done this before. I joined very class. So I've done it just a few times. And I have 1,000 hits already. So if you notice, that was what I showed here. So these are the accounts, right? And they have 1,000 hits, right? So what I did was just to save time, I did show that step, was to import that account. I imported the account into MetaMask, and MetaMask is able to get my balance that I have 1,000 bits. If this was a real Ethereum network, to show your real Ethereum balance. So this is dummy bits of my local network. So okay, let me switch to my just many accounts that I have here. This correct account? Okay, 07. Sorry, coming. Yeah. So this is my main account. This network. So if you notice, the address of the account tallies with the first account there, which is 0F3. So if you notice, you check the address, you see your 0F3 here. So I'm just using that to demo. So now I can actually I'll going to perform a demo transaction here to another address. So there's an address here that has the account here that has 0E, right? So I'm going to copy the address. I click on it to copy the address, and I'm going to take the amount of it to the address. So I switch back to my Ganache account, then I would send it to the address. Press here, and I send it to 50. Then click next. So I'll be asked to confirm. So this confirm action is actually behind the scenes is me signing the transaction to ensure that it cannot be tampered with. But when I click confirm, the transaction will be signed and will be broadcasted to the network, and I will show you that. So I'll click. So if you notice there's a gas fee, I was for that lecture. So I click confirm, the transaction is being signed and being broadcasted in the network. So watch what will happen here on my console. So the transaction will be broadcasted and it will show up here very soon. I hope this works. Oh, sorry, I have to forgive me. There's an action I have to reset the nonce. So there's something called a nonce. I will speak about this later in other classes. So I have to reset my nonce so that my transactions will not be duplicate. So duplicate transactions are not allowed. I would also explain that. So I will set my accounts so that my nonce is reset to 0. So I will just perform that operation all over again. The address, switch back to the national accounts, click and send. Then 50 eats. And I'll confirm. So confirmation is me signing this transaction. And I'll actually show you how the transaction is actually signed. I'll show you another alternative way to execute this action in blockchain. Oh, okay. Anyway, I think I'm having a POD on my computer since I'm running fine. So I will just I'll quickly move on to an alternative way of getting this done. So that I don't know, I'm having issues with some detecting my local network. So got the local network, so there could be some local issues too. So apologies for that. So I would just I'll start my network. I'll quickly just demo, show an alternative way of getting this done. So the first action, the first demo I tried showing was using MetaMask, right? So MetaMask is the user-friendly way of getting it done. For the sake of guys here who will be doing it manually, right? Who will be writing it done. So this is the alternative way of getting it done. So I'm going to send a transaction, right? I'm going to be sending a transaction. So like I said, when you start up a client that I've done here, now, once you start up a client, you can interact with that client over the internet. And one way, the way you do that is via what we call is your normal HTTP request, right? Or via JSON RPC. So JSON RPC is kind of like an engineer's way of doing what MetaMask tries to do. And so I'll be sending a transaction manually here, and we'll see how it's done. So I'll go back to MetaMask to copy the address of that account. I'll try to get it. I'll try to maybe this time. I'll try to um, do the MetaMask way in. So anyway, let me just copy the address. Let me try this. Let's get the address. Save it. Copy the address. Come back. Come back here. I'll place this address here, and yeah. So I'll execute this transaction now. Yeah. So transaction successful. Status 200. Okay, meaning then let me show you. Yes. So if you consider this is the transaction. It has arrived on the blockchain. I just highlighted it. So transaction has arrived on the blockchain and blockchain has accepted. And that's why I got the favorable response. So this response I got here is what we call the transaction hash. Transaction hash is literally the hash of the transaction. And you can actually decode it to the transaction hash to actually get your transaction body. So it's kind of an RLP kind of like hash, and I will discuss that for that class. So yeah, so let's now check our balance, see if money has moved, right? So we can easily check our balance with MetaMask. So open MetaMask, it's nice. If MetaMask doesn't work fine, there's an alternative way of getting it done too. So, yeah, very good. Okay, so I've sent some amount of money out from the savings account. I think to my savings account. So, okay, I think the money is too small. I think the money I sent is too small for it to display properly. Well, we can check the balance here too. So check the balance manually. I don't know what's going on with MetaMask. You can check the balance here. So if you check the balance, you can call. There's a method you can also called get balance. So we call the get balance to actually check. So what MetaMask is doing, right? I'm just showing you how what is really going on behind the scenes. So this is the and I want to check the balance. Okay, so this is the result. So this is the balance, and we can um, let me compare this to yeah. So if you notice, the amount I spent is exactly the same with the balance I got from call. So what this means is then I can show you on the I show you the requests to get balance. Okay. Well, anyway, it's modded up now. Yeah. So yes. So this is our balance that we got from the call. Yeah. So this is the balance we got from the call. So this is what MetaMask does behind the scene, and the results here, like I said, you compare it to the amount in value I spent, compare it to what means I have actually moved money from my from these accounts, right? These accounts successfully on my dummy Ethereum blockchain. It's a pain. It's a shame that I have issues with my MetaMask. So I would have loved to actually really show it graphically, so show it here on MetaMask. Okay, I think I can. Let me try something else. Let me try a bigger number. Wait, yeah. Just, so I will explain some of the currency conversions we have on Ethereum. So let me say 1,000 grid. So this it's in number to hex convert that. Convert this to hex. But what I'm showing is what happens behind the scenes, right? For people who will be going into development of its blockchain development. So these are the things that your code will actually be doing when you're doing this manual. So this value here, I've added 0x in front, 0x so 0x is the location for hexadecimal, same transaction again. Voila. So since transaction successful and on my blockchain, shows up on the blockchain here. I hope that number is big enough for MetaMask. For MetaMask is big experience. Oh, it's a shame. Well, anyway, that happened. Presentation can be quite funny. But yeah, so that's fine. That's all for me. If you check our balance now, you will notice that our balance has increased. So if you check our balance, so this is our current balance, right? So let me just copy it. Then I will request for the balance again. So if I press, so you will notice that the balance has increased. So this is the current balance. This is our previous. So this is our previous balance. This is our current balance. So we can convert balance back to its mean what it is. Zero plus. Rapid sequence one is going to be so the decimal. Yep. So this we can convert this number to eats. So it's approximately 3.4 eats. Yeah, so that's the amount of money that we moved from. I hope I've got this calculation correct. That we've moved from one account to the other manually via our output calls. So what I've just demonstrated here is, so this is a transaction, right? This is a transaction, and is sent to a client. So a client is the one that actually has the keys, right? So when you create so this is my final. So this is how we run the final. So when you start the Ganache instance, you will notice, so you will notice that there are accounts here. So these accounts are accounts that you can actually use to perform transactions. These are accounts that you have keys for, right? That was why I used it in my calls. If I've used any other address that does not belong to these available accounts, it will actually throw an error, saying it does not have uh, it does not have access to that account, it does not have keys to that account. I can actually demo that. Um, I think demo that just as the final. So I'll just so this is a fake account, and I just change the value there. So we try. Yep. Okay. Sorry, let me start with actually express to see what's going to say. Okay, so it's time right. So run the account. Run. Yeah, so it just shows you send that account not recognized, meaning like my client, which also manages my key, right? Cannot perform the transaction because it does not have access to the currency. They cannot perform this action on your behalf. So there's a way you can create an account and create a private key and use it in the dashing. That's what MetaMask also does for you when you try to create an account. So you can actually do this in MetaMask by creating an account. So they show that create account. So when you create account, let's just make an account name. Create an account for you. Something really wrong with MetaMask today. Maybe I should have restarted my computer. So you can create an account and you can actually see that show you the private keys of this account. So this is the address, this is the public address of this account. Now let me show you the private key. The private key is the secret piece of information that nobody else apart from me is supposed to know, right? So nothing like the password. Now, so this is the private key. So this is the key that you use to encrypt your transactions and ensure that they are yours. I mean, you cannot be tampered with. So, so that I think that I should round it up for you. Round it up. I've kind of like stretched the time. Maybe I should have taken less topics that I would still say, but not just people. So, but I hope you all enjoyed the class, and I hope I've been able to kind of like show you some things that would inspire you and make you curious enough to be able to explore these things yourself, and we'll also share resources as we take other classes. So thank you very much. So it was a shame I had issues with my paper math. I'm sure maybe if I was a bit clever, I would be able to clear up like restart things again. Or maybe I will do that another time. But I hope I think doing it manually, we've been able to achieve the same thing. So thank you very much. If there are any other questions, I'll be happy to take them and answer them.
Wow, thank you so much, Mr. Samuel. Thank you for this awesome session. Thank you for your time. I think we got so engrossed with the session. It's already 8:30. Thank you. The questions were amazing. Thank you so much. Thank you so much. I think in the absence of any question, I would not like us to hold anyone. Thank you everyone for joining in. Thank you. Thank you for joining in. It was an absolutely amazing session. Please note our sessions are recorded, and within 24 to 48 hours, we'll have it uploaded on YouTube for anyone that would like to return and watch and study one more time. Thank you so much. And remember, after each session, we take attendance. The benefit of this bootcamp will not be accrued to you if you fail in your attendance. Thank you so much. Let's continue on the Discord. Mr. Samuel shared a document earlier, so we'll be sharing it on the Discord server. If you are not on the Discord server, please do well to check your mail. The link is there waiting for you. Thank you, everyone, and wish you all a good night. Bye-bye, everyone. Thank you so much.